I'll be going over the EDA of abalone data for age predictors. The intent here is to look at what physical properties can be used to predict age for an abalone. And the obvious starting point is to use a pairwise correlation matrix. And from that, we can see here, the age column has the strongest correlation with shell dot weight, and then a bunch of additional ones, height, diameter, and length. Let's look at the R code that I used to generate. Here, as you can see, I'm using all these libraries. I load these libraries, and then I read the abalone data from a file, create a data frame with the ID column removed, and then compute the correlation matrix. If I execute this, I get this result as you could have seen in the document. So based on this, we can use a 70-30 train test split and use a bunch of linear models and see which one performs the best, which one has the lowest MAE. So let me do this, and then in this R code we can see that I used a bunch of models. So let me go back to the document and show which models performed give what kind of MAE. And as you can see, I'm using a bunch of multiple linear regression models. Only one of them is using the shell dot weight, and the fourth model has the lowest minimum absolute error. Now there is one small detail here. Basically, in a linear model, especially with multiple linear regressions, that the assumption is all of these predictor variables are independent of each other. But generally, from domain knowledge and from common sense, we can see that larger mollusks should weigh more, so the weight is related to height, diameter, etc. So to handle this situation where these predictor variables are not fully independent of each other, we can add an additional interaction term which is derived as a product of the predictor variables. So this is the final model that we're using, and that is the MAE. So we can see that adding this interaction term gave us an even lower MAE. Now let's look at how the model is performing. And to do that, we can create a plot of the residuals of that model and see how that plot looks like. As we can see, the residuals are closely grouped around 0, which is very close to a normal curve. We can see that it has a slight amount of skewness to the right, but it's very close to a normal curve. The other thing that we can do here is to do cross-validation. Here I'm doing a 10-fold cross-validation with 3 repeats. And running this, it takes a bit of time, but it actually gives the same MAE that we saw earlier. So we can say that this model fits the data quite well. And this is the final summary, which I'm not going through here, but that's kind of the end of my EDA presentation. Thank you.
The goal of the RAG application is to make our analysis accessible through natural language. Instead of requiring users to read a full report or even understand how the code works, the RAG apps allows them to ask questions about the abalone dataset and our findings in plain English. Behind the scenes, the app uses a retrieval augmented generation pipeline. We provide it with a small knowledge base containing our analysis summaries, feature descriptions, and insights from the EDA. When a user asks a question, the system retrieves the most relevant context and generates a response grounded in that information. This approach kind of allows us to bridge the gap between a technical analysis and non-technical users. In addition to the written analysis and RAG app, we also created an R Shiny dashboard that allows users to visually explore relationships in the data. The dashboard focuses on making it easy to see how different physical measurements relate to abalone age. Rather than looking at tables or summary statistics, users can interactively explore trends and patterns. This is especially helpful for exploratory analysis and for communicating results to people that are maybe not familiar with regression outputs. So I would like to do a quick demonstration of both our RAG app as well as the Abalone Age Explorer is what we call it. So let me share my screen. This is the kind of dashboard we made for the RAG app. And just a quick question I came up with is what does shell weight tell us about age? And so it goes through, it prints out an overview, the key findings from the EDA that relate to the question, where exactly the information was retrieved from, and also prints out all of the files that are stored within our knowledge base. And for the our Shiny app, we have a quick, just little explorer. It gives you scatter plots and box plots. And for the scatter plot, you could add a trend line just as something else to do. We have a few different features you could look through, and one of the nice things about the Explorer is with each feature, we printed summary statistics, which gives you the mean, the median, so on and so forth, and it changes for each of the different descriptions. So thank you very much for listening to our presentation, and hopefully you guys enjoyed it.